today's lesson is about infinite geometric. But this time, okay, it's a series instead of a sequence. And let me explain the difference. It looks almost identical. It's geometric, which means it's got an R, right? In other words, you know you're going to be multiplying to make the jumps. But a geometric sequence, and you don't have to write this part down, I just want to show you. A geometric sequence would be like 1, 5, 25, 125, right? What's R, guys? What am I jumping by? What's my ratio? 5, thank you. Okay, now that's a geometric sequence. A geometric series, okay, is written almost exactly the same way, but instead of a comma in between each one, there's actually a plus. That's the only difference, okay? And the reason is because they want you to find the sum. You can actually find the sum of a series, which that's the reason that there's pluses, okay? And that's the only difference. Now, the formula for an infinite geometric series, in order to find the sum, the formula, and this you need to write down, the sum equals your first term, so you write down your first term, and you divide it by 1 minus whatever R is. That's how you find the sum. Now, before I start, I want to, over here, I want to think with you for just a second about something. If I tell you that the ratio is 1/2, let's say, for example, if my ratio is 1/2, every time I make a jump, is my jump smaller or bigger? It gets smaller and smaller, correct? So, for example, if I told you 8, what would my next jump be? We're using series, so we're going to put a plus. What's my next jump? 4. And half would be how much? 2. Half again would be 1, right? Then 1/2, 1/4, 1/8, and so forth. Agree? Now watch this for just a second. It's kind of interesting. Now here's what's interesting. You wouldn't think, because we all know that this series goes on and on forever, right? You can always take half of something, okay? No matter how tiny it is, you can still split it in half. Well, this actually has a sum, okay? In other words, I can add these numbers up and get really, really close, all right? And let me explain what I mean by that. So I'm just going to use this calculator up here so you can see it. You can use your own if you want. But if you start with here, and I say, okay, 8 plus 4 plus 2 plus 1, I'm going to get 15, correct? So the whole numbers add up to be 15. Now I'm going to start adding these other numbers. So I'm going to add 1/2, so plus 0.5, and I get 15.5. Now I'm going to add 1/4, so plus 0.25, and I get 15.75. Right? They're not getting much bigger, are they? Now I'm going to add 1/8. Okay, what's the next number I would add? What's half of 1/8? 1/16. Right? 15.9. Okay, and then the next number would be 1/32. 15.96. It barely jumps at all, right? They're barely jumping. So now I'm going to add 164, I'm sorry. It's jumping even less, because 164 is tiny, tiny, isn't it? So now I'm going to add 1/28. Right, plus 1 over 1/28. 15.9. Right, what's it getting closer and closer to? 16. And if I add the next number, what's, if I add 1 over 256, which is the next number, 15.96, right? It's getting closer and closer. No matter how long I keep going, what's it getting closer and closer to? What number? 16. Okay? So they call that the sum of this being 16. So if we use the formula can do that for us, so you don't have to do that every time, okay? And the formula is this. If we use the formula of the sum, that's what the capital S stands for. You take the first term, which is 8, and you divide it by 1 minus r. So r, in this case, we decided was 1/2, so 1 minus 1/2. And some kids were entering this in the calculator incorrectly, so the way you do this would be 8 divided by, and you need to put this part in a fraction, 1 minus 1/2. 16, which is what we said it was, right? So the sum approaches 16, for lack of a better way, right? It's just gonna get closer and closer and closer and closer and closer to 16. Okay? Now, here's the deal. Do you think that if I went the other way with it, for example, if I had a series, okay, that went 1, 2, 4, 8, 16, and so forth. Actually, there should have been a plus there, I'm sorry. Would I be able to find the sum of that? Come on, think with me. If that number got bigger and bigger and bigger and bigger, would it approach a certain number? No. It's just gonna get bigger and bigger and bigger, right? So you cannot find a sum if r, because what is r in this case? R is 2, isn't it? This has no sum. Okay? In order to find the sum of a series, of a geometric series, r has to be between, and this is important, okay? R has to be between -1 and 1. That is very important. An infinite geometric series will converge to a sum. In other words, guys, it has to be, in order for you to find an answer, your number has to be between -1 and 1. So -1/2, absolutely, it will work. 1/2, yes, it will work. R has to be between the window of -1 and 1. Got it? Otherwise, you cannot find the geometric sum because the number just gets bigger and bigger. Okay? So now then, let's actually try a problem. Because today's lesson is super easy. Okay? The directions are find the sum if it exists. So find the sum. Number 1. 1 plus 1/2 plus 1/4 and so forth. Okay, keep in mind, I can only find a geometric sum, right? And you can check and see, first of all, is it even geometric? We learned that already. Okay? Once you find R, that's when you decide. How do you find R here? We would do 1/2 divided by what? You remember to find R? You go this way. So find R first. 1/2 divided by 1. And we're going to try another one to make sure you're right. It's 1/4 divided by 1/2. Either way, the answer is 1/2. So R, in this case, is 1/2. Does that mean it's going to have a sum? Absolutely. 1/2 between -1 and 1. So let's use our formula. To find the sum, S, you write down the first term, which is 1, and you divide by what? Remember the formula? 1 minus whatever R is, which is 1/2. Okay, so that means 1 divided by 1/2 in this case would be how much? 2. Right? And it makes sense, because if you go back up here and look on these, just these add up to 15, right? And we counted this as 1, so 15 plus 1 gave us 16. Okay? Kind of like here. This is 1, and all the fractions add up to 1, so there's your 2. Right. Now let's try another one. What about if I gave you The directions are find the sum. So 1/4 plus 1/16. The directions are find the sum. Step 1 to find the sum is to find R, because you have to find out, is there even a sum to begin with? So find R for me, please. Okay, to find R, you go backwards. So R equals 1/16 divided by 1/4, which gives you 1/4, right? And on your calculator, I would check one more to make sure it's accurate. I would do 164 divided by 1/16. Okay? Now the question was first of all, find the sum. Is there a sum if R is 1/4, you guys? Yes, it's between -1 and 1. So the formula, remember, is to take the first term, which is 1/4, and divide by 1 minus the ratio. Be careful on your calculator with that. Okay, you can use the little alpha y equals, I believe it is, that might help you, so you don't make a mistake. What did y'all get for the sum?
1/3.
Very good. Check it and make sure you're getting that, because if you're not, you've got a calculator error. 1/3 is the answer. Okay, now, here's number 3. 5 plus 1/5 plus 1/125, and so forth. Find the sum if one exists. Step 1, find R. Step 2 is R between -1 and 1. And if so, then yes, you can use the formula for the summation of a series. Go this way to find R. 1/5 divided by 5 would be 1/25, and I would check one more to make sure it's right. So R is 1/25. Is that between 0 and 1? Is 1/25? Yeah, it's a fraction, less than 1. So is there a sum? Yes, so use the formula. Formula calls for the first term, which is 5, divided by 1 minus R. Use your calculator to be sure you get it right. It's 125/24. Right? Okay. Right. Last one like this, and then we're moving to a different kind of problem. Find the sum, please. Okay, step 1 to find the sum is to find R. What is R, guys? You go this way, so R would be 3 divided by 1, So R is 3. Is that between -1 and 1? Is it? No. Is there a sum then? No. Because you can't add this up, it just gets bigger and bigger. If I add another number, it's just gonna get larger and larger and larger. It doesn't, the numbers I'm adding aren't tiny, tiny, tiny. They get bigger and bigger. So it doesn't work. Okay? So then the sum would be none. No sum. Okay, last one. You ready? Okay. The next thing is called summation notation. It's really weird. It looks like a Greek symbol. Okay, it's called summation notation. And it's a sideways M for, I don't know how else to explain what it looks like, okay? So if you're trying to do an M sideways, that's kind of what it is. And you can make these little marks going in if you really want to get technical. But it's just a sideways M. Okay? Now, so if you turn it this way, it kind of looks like an M, right? All right, so here's what all the things mean on it. It's really easy. There will be a number down here, and this is the number that you plug in first. That's the number down below. Then there'll be a number on the top, and that's the number you plug in last. Okay, so the number at the bottom is the number you plug in first. The number at the top is the number you plug in last. Okay, and then here on the side will be a rule, or you can call it a formula, whatever you want to say. And basically it's a way to get just a little part of a series, right? So if I want like the third, fourth, and fifth term of the series added together and that's all, that's what this means. Or if I want the fifth, sixth, and seventh term added together of a series, that's what this is saying. The symbol is called the summation symbol, right? And that's all it's saying. It's adding up just part of a sum, okay? So this is what I mean. For example, okay, the rule is 2K. Guys, a rule like 2K is the numbers are just going to get bigger and bigger and bigger. You can't actually find the sum. So what's going to happen, okay, is that you are going to just find part of the sum, a little piece of it. So you're going to find K is 4, so you're going to plug in the number 4. All the way to up here, we're going to put the number 9. Okay, before you do anything, let me explain what that means. You're going to start at 4, and you're going to plug in 4, 5, 6, 7, 8, and where are you going to stop at? The number at the top, which is 9. Okay, so what that means, and you're not going to have to write this out, I'm just doing notes to explain what I'm talking about. So in other words, I'm going to plug in 4 first, which would be 2 times 4. Do you agree? I plugged in 4 there, 2 times 4. What does that give me, guys? 8. Right? And then what's the next number I'm going to plug in? 5, which is 2 times 5, which is how much? 10. And then the next number, because remember we're doing a series, so use plus, because we're going to add them up. What's the next number I plug in? 6, right? So 4, 5, 6. Can I stop? Are y'all alive out there? Can I stop yet? No. I need to plug in 7 and 8 and 9. Kind of ran out of room, I'm sorry. So that gives me 2 times 7 is 14, 2 times 8 is 16, and 2 times 9 is 18. That's all I want. I don't want the whole series trying to add it up. You couldn't anyways, because it's getting bigger and bigger. Okay? I just want that piece of it. Okay, so what is the answer? Add those numbers up and tell me what you get.
78.
Thank you. So the sum of 2K from 4 to 9 is 78. That's what it means. It's not too hard. Try another one. Number 2. Okay, remember that backwards M. Okay, I'm gonna say A equals 1. And we're only gonna go a short distance this time. We're gonna go from 1 to 3. Okay, now this one's strange though. Okay, I want 8. That's it. I want 8. I know, right? That looks a little weird. Where would I plug 1 in? Is there an A anywhere here? You can't, can you? So what it's actually saying to you with this, when it looks like this, when there's just a number here, it's just telling you how many 8s I want. How many do I want? If I want 1, 2, 3, how many is that? 3 8s, that's it. It's just saying, I want 8 from 1 to 3 times. So I want it once, twice, and 3 times. Or in other words, you can just say 8 times 3. Either way is fine. That one's strange. Okay, number 3. Let's try the next one. Do your sideways M. And I'm going to tell you x is -1. So we're going to go from -1 all the way till, guys, we're going to stop with 4. And my rule I'm going to plug in. Okay, let me ask you a question. If I'm going from -1 to 4, that's going to be -1. What's next? Yeah, you can use 0. -1, what would be next? 0, 1, 2, 3, 4. Okay, and we're going to plug it into 2 to the x power. Okay, so let's start. I want 2 to the negative first power. Then I'm going to need 2 to the 0, 2 to the 1, 2 squared, 2 cubed, and 2 to the 4th. Those are the numbers I need, don't I? I plugged in -1, 0, 1, 2, 3, 4. And what do you do with those numbers? You add them up. So 2 to the -1, it flips it. That's 1/2. 2 to the 0 power. What is anything to the 0 power?
0. Oh, 1.
1. It's all right. 2 to the first power is 2. 2 squared is 4. 2 cubed is 8. And 2 to the 4th is 16. You're just going to add just those numbers up only. Try adding them in your calculator. Did you get 31.5? Okay, last problem, number 4. Put your sideways M. X is -3 to 2. Okay, if I go from -3 to 2, I'm going to have to input -3, -2, -1, 0, 1, and 2. You'll see it? And the rule is -2x minus 5. But what does it have around it? What are those?
Absolute.
Absolute value. In other words, you're going to plug these numbers in, but you're only allowed to write the positive answer. So the first number I'm going to plug in would be a -3. So -2 times -3 minus 5. So that gives me 6 minus 5. What is 6 minus 5?
-1.
1. And what's the absolute value of 1? It's just 1, so you're safe with that. Now the next number after -3 would be -2. -2 times -2 is 4. What's 4 minus 5?
-1.
-1. But I want the absolute value, so what am I going to write down? 1. So I did -3, -2. What's next? -1, which is 2 minus 5, which is -3. But I have to write the positive value, so there's 3. Now you're going to plug in 0, which gives you -5. So you write 5. And then you plug in 1 and 2. You do 7 and 9. Add them up for me. Find the sum. What'd you get? Thank you. 26. Okay, you're finished. You can work on your worksheet now.
Yes, I would.